What's up, Math Nation? Mr. Cornell. Hope everyone is relaxed today. Today we are going to go over a circles part 2, and that is identifying equations of circles. It's pretty straightforward, nothing too crazy. So just sit back, relax, and enjoy the show. So right here I have a coordinate plane here showing part of a circle and a nice little right triangle here, identifying this point as x comma y. So in this grid below, a portion of the circle whose center is at the origin, so remember that's 0 comma 0, and whose radius is 10. So you're looking at a radius of 10 here. So this is going all the way from there to there as 10. So it's saying, what is true about every point that lies on this circle? So it's talking about this point, this point, this point, this point, that point, all of those points there. Well, what is true is no matter what point I choose and I draw that back to the center, they are all of the same distance, okay? I am drawing, it doesn't matter if I picked a point from over here and drew it over to there. They will all have the same distance, okay? Which in definition is showing you a radius. So every point, okay, is equidistant from the center. Okay, it is equidistant from the center. Okay, let's get rid of all this mumbo jumbo. Okay, now next. Algebraically, show that the point 6, 8 must lie on the circle. Okay, so now, let's just pretend for a second that this is point 6, 8. Well, the x value from here to here would be 6. The y value, okay, would then go up from that point would be 8. Well, if that point was on the circle, then what would this value have to be? Survey says 10, right? It would have to be 10. Now, why does it have to be 10? Because it's going from the center to that point, which was what we just talked about, is the radius of that circle. So let's figure that out. Well, what formula are we familiar with the right triangle when you have two sides and you're looking for the third? And you said the Pythagorean theorem. So the question is, well, what is 6 squared plus 8 squared equal to? Well, what is 36 plus 64? Well, 100 equals c squared. The square root of 100 is 10, and that indeed is what the radius of the circle is. So 6 comma 8 must lie on that circle. Now, if you look at this particular one, if I counted 7, it's like right over there. It looks like that's on the circle. Well, is it on the circle? Well, let's figure out. Is 7 squared plus 7 squared equal to 10 squared, which is the radius? Okay, this is, remember, is our x point, and then this is our y point, and then it has to be 10 because that has to be the radius of the circle. Well, the question is 49 plus 49 equal to 100? No, it is not. So 7, 7, while it does look pretty close, it is not on the circle. Now, what's the point of all this? Well, the point of all this is this actually defines what the equation of a circle is. So if the point x, y lies on the circle, so that's like practice problem letter B we just did, write an equation that must be true involving x and y based on the right triangle. Well, what did we do? We took the x value and squared it, and the y value and squared it, and that had to be equal to, what was this? The radius squared. X squared plus y squared equals r squared. And that would be true to any point that is on a circle. And that's what they're showing you here, equations of a circle. Now what's important here is that you're centered at the origin. The next lesson we'll get off the origin, but for right now we're going to stay at 0, 0. So a circle whose center is at the origin, 0, 0, and has a radius r. X squared plus y squared equals r squared. All right? So now let's do some practice problems involving that. So the point 7, 4 lies on a circle centered at the origin. Write the equation of the circle and state the radius, right? So we know that a formula right now is x squared plus y squared equals r squared, okay? We don't know what the r is, so we're going to use this point to create that equation, right? So we're going to do 7 squared plus 4 squared equals r squared, and we're going to do all sorts of math and figure out what r is. 7 squared is 49. 4 squared is 16, and then 49 plus 16 is 65, and that's all r squared. Now remember, to figure out the r, we're going to take the square root of 65. Now, for my case, I'm going to leave it like that because it's nice and pretty. If it was, say, 64, I would say, oh, it's 64, and then I would just write a nice pretty number, but we're going to leave it like that, okay, for now. So now the equation of the circle, okay, because we know our r value, would then be x squared plus y squared equals r squared. We just figured out that r was 65, so x squared plus y squared equals 65 is the equation of the circle. There you go. That's simple. So don't make it harder than it has to be. Plug and play. So now, do what we did before. Is the point negative 8 comma 1 also on the circle? Well, let's figure it out. Is negative 8 squared plus 1 squared equal to 65? Well, oh, if I don't put that in parentheses, I get the whole thing wrong. So negative 8 squared is 64. 1 squared is 1. 64 plus 1 is 65. And since they are equal to each other, yes, I'm happy to report that negative 8 comma 1 is on the circle. Okay. So let's just keep going with that. For what we understand, the center of x squared and y squared is going to be 0, 0. Now, remember that this equation is saying this. X squared plus y squared equals r squared. So in here, it's saying that r squared is 25, which means that the square root of 25, that the radius is 5. So if I'm going to graph that, I'm going to go 5 here, negative 5 here, and negative 5 there. Which means there it is. More or less. There is a circle with a radius of 5. Okay, and I use those points because it's easy to count 5 when you're moving straight. I'm not going to try to count 5 on this diagonal here. Okay. So now, let's look at a circle that is not centered at the origin. So here we have a circle that's drawn, and right there, that's the center, and that's at 2, 3, and has a length of 5 units. So here, from here to here is 5, there, so it's moving at a radius of 5. So is the circle congruent to the circle we constructed? So is this circle that is centered 2, 3 congruent to the circle that we drew up above that also had a radius of 5? And we said, oh, yes, it is. Yes, it is. So is there a sequence of basic rigid motions, okay, that would take this circle and center it at the origin? So can I get this and move it to here with one of the rigid motions? Remember, rigid motions could be a translation, reflection, or rotation. So all we want to do is we want to move it. So you'd say, yes, we could translate, which basically means to move the circle. Okay. I don't want that. So the equation of this circle can be found using the same pattern to move the center of the circle back to the origin, okay? So, well, what does that mean? Translation, if I'm going from 0, 0, moved it 2 to the right and 3 up. That's how you got to the point 2, 3. So the equation of a circle comes from doing that backwards, which would mean that instead of going 2 to the right and 3 up, I would be going 2 to the left and 3 down, or 3 down and 2 to the left. That's what's going to create the equation of the circle, okay? So then the equation, so watch, I'll just tell you the equation and then you'll see where those numbers came from. So the equation of this circle would be x minus 2 squared, y minus 3 squared equals 5 squared, okay, or 25. And then again, where the x squared and the x and the y comes from the x and the y, right? Square, that's the points. And now this minus 2 came from moving this center 2 spaces. And then this minus 3 came from moving that from the center 3 spaces down. Okay, that's where your equation of a circle comes from. And then this is your standard form or the formula you want to memorize. X minus a squared, y minus b squared equals r squared, where a, b is the center, wherever they may or may not have moved it to. And your radius is r. Okay? So let's do a couple of examples, and you'll see that I'm not trying to trick you, that it's actually pretty simple. So here it says, write the equation of the circle that is graphed below. So the center is, so I like to do it like this. So I say the center is negative 2 comma 4. The radius is, what's this distance? 2. And they're all the same, so the radius is 2. Now the equation of a circle is x minus a squared, y minus b squared equals r squared. Plain and simple, take the center, change the signs. Okay, that's what this minus thing there is trying to tell you in the formula. So the x value is negative 2, so I'm going to write positive 2. The y value is positive 4, so I'm going to write negative 4. And the r value is 2. So you can either write it like this, or you can write it x plus 2 squared minus 4 squared equals 4. Okay? It is that simple. Center, formula, change signs. Here we go. Find the radius in the center of the circle given in this equation. So right here, this is going to tell you the center. Okay, that's going to tell you the center. And now what did I just say 5 seconds ago that you do to those signs? Change them. So it's going to be negative 12, positive 4. This tells me my radius, but remember the formula is x squared plus y squared equals r squared. So r squared is 81, which means r is 9. So your radius is going to be 9 because I square rooted that. So there you go. All right, let's try 7. Write the equation of the circle. So change his sign, negative 9. Now you're going to say, well, 0, what are you supposed to do with 0? Think about it. The original equation we said was just x squared plus y squared equals r squared. This, the center, was 0, 0. So when you have a center value, whether it's x or y, is 0, you just write either x squared or just y squared. So here I change the sign, so I'm going to write x minus 9 squared. Since it's y, I'm just going to write y squared since it's 0. And since the radius is 7, I have to do r squared. 7 squared is 49. And there's your answer there. Alrighty. And I cannot let you go that easy. I have to try to make you think a little bit. Okay, so this is now the ending to our story. 2 points in the plane A and B represent the endpoints of the diameter of a circle. Okay, so in this case, you have, I'm going to sketch this real ugly here. So right here is negative 3 comma 8, and here is 17 comma 8. Those represent the diameter of a circle. So then that's going to be right there. So that means the center is going to be somewhere over there. That's more or less very ugly what they're trying to tell you or show you in this particular case. So the first question is, what is the center? What is the center of the circle? Now, for this particular example, it's really easy because since the y values were the same, it's actually just a straight line. And you would just say, well, I could count the distance from here to here, which you'd say is 20, right? And half of 20, because it has to be the circle, is 10. So you could just always count 10 spaces from there, 10 spaces from there, and then you would find that point and that point could be 7, 8. Okay, that's kind of, if you're going to draw a graph, you kind of find the midpoint of that. Oh, there you go. Well, what happens if it's not? Well, you can find the center. The center is the midpoint. Now, the midpoint formula is always x1 plus x2 divided by 2, y1 plus y2 divided by 2. Negative 3 plus 17 divided by 2, 8 plus 8 divided by 2, ends up giving you the same answer, 7, 8. Formula, counting, okay? What is the radius of the circle? Well, we just kind of counted the whole thing. We figured out that the diameter was 20, so that means that the radius would have had to have been 10, because that's the distance from here to here is 10. Well, this is actually, if you need to show work, or if you have no idea how to count it because maybe it's diagonal a little bit, you're going to use the distance formula, which says x2 minus x1 divided by 2 plus y2 minus y1 divided by 2. Okay, that's a minus there. Now you're not going to use these points because that's the diameter, and if you do, you better divide by 2. You should really use the 7/8 and either the 3/8 or the 17/8. It does not matter which one you're going to do. Let's say I'm going to use 3/8 and say 17/8. I would do 17 minus 3 squared, and then 8 minus, no, it's not 17 minus 7. 17 minus 7 squared. I should do this because you're probably saying, why is it so sloppy? I try my best here, people. You don't have to criticize everything I do. Okay, this is not 3/8, it's 7/8. Okay, center, 7/8, endpoint, 17/8. Here we go. 17 minus 7 squared, 8 minus 8 squared. That's going to give you the square root of 100, which is 10. Write the equation of the circle. Well, the equation of the circle, I would need the center, which is 7 and 8. I would need the radius, which is 10. I change the signs. So I have x minus 7 squared plus y minus 8 squared equals 10 squared. And remember, again, you could always just say equals 100 if you do 10 squared. All right, last but not least, we come in for a nice soft landing. Determine the center and radius of the circle whose equation looks like this. Now this looks totally different than anything we've done, because anything we've done, it was always x squared and y squared, or x squared plus or minus, or y squared plus or minus. There was no 5 multiplication. Well, you can't, it's because you can't have it there. So what we have to do is we have to take it out. And we can very easily take it out by doing, remember, because in math, if you do one thing, you do it to everybody, and you're allowed to do that, just do that. So if you don't want 5 there being multiplied, then just divide everybody by 5, and then they all go away. So I would divide you by 5, I would divide you by 5, and I would divide you by 5. Now, if it was a 2, I would just divide everybody by 2. Sometimes that could throw you off a little bit, but for this case, no, we're good. Because that's 1, that's 1, and 180 divided by 3 is 36. 180 divided by 5 is 36. There you go. Now this is in our standard form. So our center would be 0, 0. That's right here. And then the radius, r squared, is 36. So what's the square root of 36? 6. All right. There we go. We did it. Have any questions? Leave some comments. Those who can, text, comment, whatever you need to do. Have a great day, everybody.